Section 5.3, the ellipse. So an ellipse is defined as the locus of points in a plane, the sum of whose distance from two fixed points, two focuses, is constant. So what they're saying here is this red line, those distances, whatever distance that is the same as this distance. So no matter what point I chose on the line, if I added up its distance to the foci, it would be the same number, no matter where I chose it to be. Okay? And relationship, so it says A to F1 plus A to F2 is equal to B to F1, B to F2, the sum of the focal radii. Those distances are all the same. That's how a ellipse is defined. Okay, a couple characteristics about an ellipse. There's something called the foci, and those are called F1 and F2. Those are two fixed points. The major axis is, because like it's an oval, it's that longest way. So this is that major axis. It goes from vertex 1 to vertex 2. Okay, and we're going to see where we will have ellipses that are this way, and that's the major axis then. Okay, the minor axis is the narrow way, so that distance there. And there's also a center. Okay. Your general equations look something like this. So we have an h and a k, that's going to be our center. And then we have a squared and b squared, and we always have it equal 1. Okay, so the thing that tells us whether it's a wide ellipse, whether it's this way, is a. And a is going to be your bigger number between a and b. And if a is under the x, then it looks like this. If the bigger number is under the y, then we have a narrow ellipse. We have an ellipse that looks like that, okay, on the xy plane. Okay, so the other thing I thought I would tell you is this relationship. A is always greater than b, and something else is c squared is equal to a squared minus b squared. Some of you are saying, well, what is c? C has to do with the focus, and we'll see that in the examples, okay? So this is a pretty important page to be looking at. Oh, here they tell us about c. Okay, so the length of the major axes, so in this case, this major axis would be from vertex 1 all the way to vertex 2. That entire length is called 2a. The minor axis is 2b long, and the from the focus to the center is called length c. And again, that relationship c squared equals a squared minus b squared is important. Okay. Let's try some problems here. I think I left some writing by accident. Okay, so determine all the features of this ellipse. X squared plus over 16 plus y squared over 4 is equal to 1. First of all, we can tell this is ellipse. We have some x squared and y squared, and it equals 1. So the bigger number right here is under the x squared. So this must mean that it is this type of ellipse. It is a major axis is horizontal right here. Okay, so I'm thinking of my ellipse looks like this. Okay, its center is at h and k. We have no x minus h, x minus k, so that means the center must be 0, 0. A, remember this is a squared, so a is equal to the square root of 16, which is equal to 4. This is b squared, so b must be 2. Remember to find c, we use the relationship c squared is equal to a squared minus b squared. C squared is equal to 16 minus 4. C squared is equal to 12, so c is equal to the square root of 12, which is 2 root 3. So that's our c. Okay? the major axes. Remember, the major axis length was 2a, so that's 2 times 4, which is equal to 8. The minor axis length was 2b, or not 2b, which is 2 times 2, which is 4. Okay, the vertices are located, so let's look back to our quick little diagram. So my vertices are going to be here and here. And remember we said this entire length was, the major axis was 2a, or 8 units long. Well, by symmetry, we can tell then that this is going to be 4 and 0, and this is going to be negative 4 and 0, because our length, again, was 8 right there. Okay, so, oops, come on, computer. Oops, where am I here? Right here. Okay, so my vertices in this case are going to be 4 and 0 and negative 4 and 0. And what we did to get that is we said it was plus or minus a and 0. So we just took that length a. And this is only if horizontal. That's the general rule. Okay, next is the focus. So remember, the focus in this case would be somewhere here and here. And C, this entire length was C. No, let me think about this. This entire length was how long? Right here. This length was C from the center to the foci. That length was C. Not both of them C, just this one single length. And we said C was 2 root 3. So this is going to be positive 2 root 3, and that's going to be negative 2 root 3 to there. So we're going to have 2 root 3 and 0, and negative 2 root 3 and 0. And so in general, what that was is plus or minus C and 0. And again, this is only if horizontal. So this is your very good horizontal example. Okay? For some reason, I forgot to clear all my ink. Okay. It says determine all the features for this ellipse. So first of all, before we can do anything, we need to get our form so it's x squared over a squared, or x squared over b squared, plus y squared over something equals 1. So in order to get it to do that, I need to divide everything by 400. Okay, so this simplifies to x squared over 16. This simplifies to y squared over 25 equals 1. Okay, so right away I see that my bigger number is under my y squared. So this must mean that it is a vertical ellipse. It looks like that. Okay, so my center, again, I don't have any x minuses or anything, so my center is still 0, 0. My a is going to be the square root of 25, which is equal to 5. My b is going to be the square root of 16, which is 4. And to find c, remember I say c squared is equal to a squared minus b squared. So that would be 25 minus 16, which is 9. So if c squared equals 9, c must equal 3. Okay? So the length of my major axes is always 2a, which is going to be 2 times 5, which is 10. My minor axes is going to be 2b, which is 2 times 4, which is 8. Okay, so now let's think about our vertices here. So our vertices are these points right here. Remember that this length is 2a, and a is 5. So we're going to have, remember my x is going to stay 0. It's my y that's going to change in this case. So I'm going to have 0 and 5. And 0 and negative 5. So in other words, what we did is we did 0 and plus or minus a, and this is if vertical. This is our vertical example. Okay. Our foci are going to be right here, right there. Remember that length is called C, and in this case C is 3. So we're going to have 0 and 3 and 0 and negative 3. So in general we did 0 plus or minus C. So just a general formula there. Okay, of course we're going to get more difficult. Okay, we need to determine all of the features for this ellipse. So this is now no longer in standard form. This is all in general form. We want to get it to equal 1, and I'll walk you through this process. Okay, so the first thing I'm going to do is I'm going to take this constant to the other side. I'm going to rewrite this as 9x squared, and I'm going to put all my x's together. Minus 18x plus 25, putting all my y's together, is equal to negative 9. Okay, now I'm going to complete the square, and that's going to help with my center. Okay, so what I'm going to do is I'm going to just kind of group the x's, group the y's, and go about completing the square. So out of this, I'm going to take a 9. I'm going to be left with x squared minus 2x, and I'm going to leave space because I'm going to somehow complete the square there. Oops, let's do some similar brackets. Okay, here I'm going to take out a 25. I'm going to have y squared minus 6y, and I'm going to leave space because I'm going to complete the square, is equal to 9. Negative 9. Okay, so now I'm going to go about completing the square. Half of negative 2 is negative 1. Negative 1 squared is plus 1. So let's think about this. I have 9 times 1. So if I added 9 times 1 on this side, guess what? Go away. Okay, I am going to have to add 9 to this side because it's an equation. Okay. Before, I think we did everything on one side of the bracket here. I'm just showing this way because some people prefer this way. You can do it the other way as well. Okay, to complete this square, we have minus 6. Half of minus 6 is negative 3. Negative 3 squared is 9. So I added 9. No, I didn't really add 9. I really added 25 times 9, which is 225. So if I added 225 to the left side, I have to add 225 to that side. Okay? So simplifying this now becomes 9 times x minus 1 squared. We completed the square, so we could do that. Plus 25, this is y minus 3 squared, is equal to 9 plus 9, negative 9 plus 9 is 0, and I'm just left with that 225. Okay, so in order to get 1, because remember in an ellipse everything here has to equal 1, I have to divide every term by 225. Okay, when I do that, and I'm just running out of space, this simplifies to x minus 1 squared over 25 plus 25 over 29, so y minus 3 squared over 9 is equal to 1. And that's the exact form that we wanted it to be. Okay, so first of all, notice that my center is h and k, so it's going to be at 1 and 3. And that's where I put it right here. So it's at 1 and 3. That is my center. Also, we notice, whoops, 1 and 3. We notice that my bigger term is under my x, so that's why it is a horizontal ellipse. Okay, my a value is going to be the square root of 25, which is equal to 5. My b value is going to be the square root of 9, which is 3. And to find c, remember it was c squared is equal to a squared minus b squared. So 25 minus 9 is going to be 16. The square root of 16 is 4. Okay. The major axis is 2a, so 2 times 5, which is 10. The minor axis is going to be 2b. 2 times 3 is 6. Okay, here's where we got to do some thinking. My vertices. So my vertices are going to be located here and here. So you'll notice right away that y value is going to be the same as the center. And my y value of my center was 3. Okay. The only thing that's changing now is I'm going a away from each. Okay, so I have 1 plus a, 1 plus 5 is 6. And then I go 1 minus 5, so 1 minus 5 is negative 4 to give me these 2 points. Okay, so let's think about my foci. So my foci are going to be somewhere in here. Okay, so again, they are along the same as my center, but they are C length away. Okay, so I go from my center at 1, I add C to get 5, so 1 plus 4 is 5, and then I go 1 minus 4, which is negative 3. Okay, there we go. I could also, remember, I could find those points as well, but those, they didn't ask us to do that. Okay, let's do another example. Okay, it says, oops, not what I wanted to do. Clear ink, there we go. Determine the equation of the origin-centered ellipse if one foci has coordinates 3, 0. So here's my one foci. One vertex has coordinates 4, 0. It's right there. Express the equation in standard and general form. So where we're going to begin, I sketched this ellipse to find A, B, and C. Okay. So here is my vertex at 4 and 0. So I know that this length is going to be A. Okay? I know that this length right here from my focus, which was at 3 and 0, that's going to give me C. So because, and I know that the center is going to be at 0 because it already gave me that y coordinate. And sorry, it also said origin center. That was the main reason. Okay, so I'm just going to find b, because b is going to help me here. Remember, c squared is equal to a squared minus b squared. 9 is equal to 16, because 4 squared, this was 3 squared, minus b squared. So b squared is going to equal 5. What I did, oops, is I took my b over here and my 9 over there. So b is going to be the square root of 5. Okay, and that should help us do a couple things. Okay, so because it's centered 0, I know I'm going to have x squared plus y squared is going to equal 1. And I just have to find the numbers that go underneath. Okay, so this is a horizontal ellipse. I know that because my vertices and my foci were on the x coordinate. So I know that my bigger number is going to be under x. So my a is going to come under x. Remember, I said a was 4, so a squared is 16. I know that b is going to come under here. My b was root 5 squared is 5. Okay, so here I have standard form, and now I need to make this into general form. And what I'm going to do is I'm going to multiply by every single term by 16 and 5. So I'm going to multiply by 16 times 5, 16 times 5, 16 times 5. And what that does is that gets rid of my fractions. So I'm left with 5x squared. Oops, my 5's cancel out. My 16 stays, 16 y squared, and 16 times 5 should be 90. Okay, that's not quite general form. I need 5x squared plus 16y squared minus 90 is equal to 0. And that would be general form. So this was standard and general form. Okay, Last thing, remember we're looking, this is general form, ax squared plus by squared plus cx plus dy plus e is equal to 0. You know it's ellipse if a does not equal b and both are greater than 0. Okay, so that's how you can tell that that the equations you are looking at are ellipses.